Okay, now we're moving out of sequences and onto series. Before we get started with the finite arithmetic series, I want to focus on what is a series and do some work on sigma notation. So let's go straight in. Previously we had done sequences. We know that arithmetic and geometric sequences are all about finding the nth term in a sequence. Now a series, although the name can be misleading, is all about finding the sum of a sequence. This is a very useful definition to remember. I'm going to highlight it here for you. So if we look, previously we said a sequence is a whole bunch of terms separated by a comma. Now a series is the sum of those terms. As you can see, we've got all our pluses. It's adding all those terms up. If we look at an example, we have the sequence 2, 4, 8, 16, 32. We know that what is the sum of the first three terms? So i.e., this is term 1, that's term 2, there's term 3. So we will know what is the sum. That would be T1 plus T2 plus T3. So S3 would be 2 plus 4 plus 8, and that's 14. So we've calculated the sum of a finite series. Why is it finite? It's because we only went up to T3. We did not keep going to infinity. We'll get into that later. Sigma notation. Why do we use sigma notation? It's just a fancy way of showing the sum sign. So we have this series, 2, 4, 8, 16, 32. We know previously that we could find S3 by T1 plus T2 plus T3. What if we wanted to find S3 to 5, i.e. S of the third term plus the fourth term plus the fifth term? How would that look? T3 plus T4 plus T5. Now this is not a good way to show it. We don't use that. We come to a thing we call sigma notation. Now sigma notation is just a fancy way of showing a big sum. This is sigma right here. That is what sigma is. And that is all it is. It has a couple of numbers around it, and we're going to explain that. What this is saying is n starts at 1 and ends at 3. So here we were starting at 1 and ended at 3. And this is the formula. So if we were to start at 1, 2 to the power of 1, that equals 2. 4 is 2 to the power of 2, that equals 4. 8 is 2 to the power of 3, and that equals 8. And that's how we get the answer of 12. This can be even more useful. And our second example here, what if we wanted n to start at 3 for the exact same equation and end at 5? Then we have 2n, we know that 2 to the power of 3 is 8, plus 2 to the power of 4 is 16, plus 2 to the power of 5 is 32, and that would give us our answer of 56. In general, this is the formula we use. Do not get too confused about notation, but essentially what it's saying now is I starts at m, it ends at n, for each term I. So I starts at m, we get the sum of this term I, starting at m and ending at n, going up in steps of 1. Here we got term m, this is the next term, term m plus 1, and the very last term will be term n, where we sub m into the term. So let's write the following in sigma notation. No better way to do it than example. So we have 14, 11, 8, 5. The first thing we need to do is figure out what kind of sequence this is. Now, it could be an arithmetic series linear type, and we know that this is the formula. Could be an arithmetic sequence quadratic, and we know that this is the formula. Or it could be a geometric series, and we know that this is the formula. Now, what do we know about an arithmetic sequence? It has a constant first difference. What do we know about arithmetic sequence quadratic? It has a constant second difference. And what do we know about geometric? It has a constant ratio. Let's have a look here. Immediately we should be able to see that there's a constant ratio here. What is 11 minus T3 or T2 minus T1 is negative 3. So let's do that. What is T2 minus T1? That is equal to negative 3. What is t3 minus t2 is also equal to negative 3. So we know that we have an arithmetic linear sequence here. Okay, so how can we solve this? Let's put this into the formula. We know that arithmetic linear sequence has a, which is the first term, we know that's 14, and has d, which is the difference, we know that is negative 3. And here we can go on to calculate, sub that in, and we get 17 minus 3n. Now we got our formula for Tn. This is the term general that we looked at previously. Now here we got I equals m, Ti and n. Like I say, do not get confused by that and that. Okay. We have a look here. We just sum this up in our own mind. We say it's 14 plus 11, 8 plus 5 is get 38. This is how we put it into a sigma notation. We say n starts at 1, ends at 4. Why do we have that? Because we have 4 terms here. 1, 2, 3, 4. Every single time we take 17 minus 3n and we sub in 1, 2, 3, and 4 to get these 4 numbers, and we sum it up to get 38.